So in this video, we'll look at some of the new functions in OpenCV. So this is to detect the dominant color for this area. So I've gone to like 50, 50, 100, 100 and take a rectangle and find the dominant color in that particular rectangle. So remember, like, this is not the coordinate of your stage, which runs from 0 to 480 and like 360 in height. So this is like the actual coordinate of the image, so that would depend on your computer resolution. So another thing to note, like, we have added this new function, so like you have to set the image format. So for my computer it's generally RGB, so like I'm using that as RGB. Now if I run this program, it will give me the dominant color of that particular area. So sometimes it's not correct, but it's okay. So this seems to be the color. So let me just go into costumes for this. Let me flood fill it with some other color, let's say red. Now let me run it again. So in my test, I couldn't find it 100% reliable, but still like it can detect like between blue, red, green balls kind of thing. So the other example I want to show is about the line detection. So like we clear any previous detection, turn off the video, capture image from stage, and because the image is RGB format, so I converted it from RGB to grayscale, then run the edge detection. Then I'll like specify like how much gap, maximum line gap I need to detect. So for example, if like broken lines, so like it should consider as a single line. So like between those two broken line, what is the maximum gap it can be? What is the minimum length of the line I want to detect? So if it's like a very small line, I want to like ignore it. And then I can run this huge lines using threshold. So let's just run it. So you can see like it can detect lines, and I can get the number of lines also, and I can get the lines starting position, end position, using that function. And using that, like, I can detect the slope and theta for that lines and can figure it out. For example, in a line following robot, I can detect like whether I have to turn left or right based on the angles, theta and the slope of the lines. So this is another example of line detection. So we are also applying thresholding the image and then doing that edge detection, and on the edge detection we are detecting the lines. So like this will detect this big lines of the road. So this is another example of filtering function. So here like we are doing the same thing, capturing image from stage, converting into grayscale, and then applying threshold. So let me just show you like this part of function. I'll just save that image and show you. So this is our image. So this was converted into grayscale and then we had applied the threshold. Now you see like there are a lot of this small things which are like not important for me. So I can like apply this morph open and close. So like this will like remove all that small things and like close all the big things into a single one. So let's just see the example to make it more clear. So I'll again run and save it. So you can see the difference between this image and this image. So it has removed all that small areas which can be noise. So like if you want to detect edge detection and figure it out path, so it makes it much easier using these two operations. So this is our example of a line following robot. So like the I had just drawn this line using brush on the screen canvas, and I'm just like capturing the image from the stage. So this is just to simulate like if you have a camera on a robot and like it is seeing a line. So this is just to simulate that. Now I have like cropped the image from 0 to 400 position. So like this is 0 0 in the actual image, and this should be like 0 400. So remember like our image on this machine is like 600 by 450. So like this is 0, this is 600, this is 0 0, this is like 600 450. So I'm going like here, and then like I'm just cropping this lower part of the image. So that's what I'm doing here. Then I'm just running grayscale conversion to the cropped image, and then I am like running the threshold but binary inverted, and then I'm closing any small noise, removing any small noise. Then I'm just finding contours, and if the contours is like greater than 0, I set the x position to the contour x plus the width divided by 2, so kind of here. And then I'm broadcasting line detected, and when it detect the line detected, it will go to that position, and y position I have just randomly set it to -160. So it will figure it out the x position and will go to that particular x position middle of the line. So this is like to detect the line for your line following robot. So using the x coordinate of the line, you can detect whether the robot has to move left or like the robot has to move right. So let's just run it and see. So you can see like it has detected the line, and this ball will automatically go in between of this detected line. So these were the new functions, like we have to first set the image format also. So it can be BGR also. And then like for conversion also we have to specify like we are converting from which format to grayscale or like which format to HSV. And this is the crop function, this is the threshold function, and this is the dominant color function. So this can replace your color sensor, and this is the noise filter morph operation, and color filter we had already seen in the previous videos, and this fine contour functions also we had seen in the previous videos. Circle detection also we have seen in the previous video. This is the new line detection functions which we have added. So I hope this video was useful for you. Please do like, share and subscribe. Thanks for watching.